All right. Now we go to the next. So this actually, the Bluetooth that we described was not really designed for IoT because they didn't really know about the IoT at that time. There was no IoT in 1990s, 9 or whenever they were doing this thing. And mostly it was for the headset, Bluetooth, and for the phone company to be able to talk to between the phones, as I said in the beginning, right? So if you want to call that IoT, yes, it was for the phone. But now we are really need something for the IoT. And the IoT requirements are slightly different. So here is what the IoT requires. If there is a sensor, let's say temperature sensor, it will just keep saying 30 degrees, 30 degrees, 30 degrees, 30 degrees, and every second, maybe every minute or maybe every hour, it will say that 30 degrees, and that's it, no more. Right? If you have a speedometer, it will say 55 kilometers per hour, and maybe every second it will change that number, but that's all. And same on so forth. The meter, electric meter will say kilowatt hour. So the idea is that the data is very small. It is very repetitive. Okay, and it is either event triggered or polled. Event triggered means something happens, and then which could be simply a clock. Every second I'm going to do that. That's an event, right? Or polled, when somebody asks what is the temperature, then it can say 30 degrees. So we need a gateway device to transfer it to the rest of the internet, and so therefore the sensors do not need to speak too much. They just need to speak to the gateway, right? And so they designed then Bluetooth Smart, which is also called Bluetooth Low Energy, which is also called Bluetooth 4. So the energy here is 1/2 to 1/100th of Bluetooth Classic, and we will see how that energy goes down. And this is designed for very short broadcast, such as your body temperature, your heart rate, your automotive, industrial, and all those things. This is not designed for watching a video. This is not designed. This is actually Bluetooth 4 you can use for audio as well, but this part, the low energy part, is not designed for watching a video or things like that. Okay, this is just for those things that we talked about a minute ago. So the messages are very small, and the data rate is very small. 1 megabit is good enough. Throughput is not really important, it's the delay. If anything, throughput is not, because it is very, very low. You might have, let's say, 32 bits every second. 32 bits per second is nothing, right? Battery life is critical, and that is required, that you want, as we talked about, it needs to be in years from a coin cell. And topology is simple, again a star, so they don't want to do any scatter nets. Remember that nets connecting to other nets, so routing, etc. is not an issue. Lower cost than Bluetooth Classic, and now it is even more competitive. Previously, Bluetooth was this only way to do some things. Now there are so many competitions, such as Zigbee, that we will talk about in the next few lectures. So they want to be lower cost, and new protocol design based upon Nokia's Vibri technology. So now the Bluetooth came from Ericsson, the original Bluetooth, and we learned all about it so far, right? But then they figured it out that if we do it that way, then we cannot, reduce the energy too much. So this is a totally new protocol with the same name, Bluetooth. Okay, it's the same thing like Ethernet. The original Ethernet was CSMA-CD, and then after some years, somebody came up with 100 megabits and gigabit, and they said we don't need to do CSMA-CD. So there is no CSMA-CD in the Ethernet, but we still call it Ethernet. So same thing here. The Bluetooth new and the Bluetooth old are very different, but the same name helps because people just buy it because it is Bluetooth. Although it might have two different protocols. When it talks to the old Bluetooth, it does this way, and when it talks to the new Bluetooth, it does totally differently. Two different modes, but they are Bluetooth, right? So the name is same, but the different technology. And we don't need to know about Vibri, but this was something that the Nokia had developed, and we will see. And so basically chips that you get for Bluetooth 4 are dual mode chips. right? Bluetooth Classic and Bluetooth New, Bluetooth LE. All smartphones, iPhones, Android have dual mode chips. So the Phi is slightly different, and so it uses the same 2.4 gigahertz. It can go up to 150 meters in the open field. Obviously, if you go from here, the wall is a problem, and so it might go a little bit beyond the wall, but it will not go 150 meters. Same star topology, and they use 1 megabit per second Gaussian frequency shift keying. Okay, so Gaussian FSK. This is FSK. FSK is frequency shift. When you want to transmit 1, you do one frequency. When you want to transmit 0, you do another frequency. Right? This is FSK. We have talked about amplitude shift keying, phase shift keying, frequency shift keying. So this is FSK is this. Gaussian is basically, instead of having a square pulse, you have a Gaussian pulse. So this is like a normal distribution. Gaussian means normal distribution. It's not actually exactly normal, because normal doesn't go to 0 until infinity. So this one is, it just comes down after some point. So this is closer to the normal distribution. So this is called Gaussian frequency shift keying. Now, so the reason for doing Gaussian behavior than this one has something to do with the radio communication, which we will not go here in detail, but that is better than FSK. Okay, makes it longer distance and lesser or whatnot. So anyway, so this is what I use, GFSK, Gaussian frequency shift keying. And they hop on 40 channels with 2 megahertz spacing. So instead of 1 megahertz, 2 megahertz spacing. So there are 40 channels. The channels are numbered from 0 through 39, not sequentially like that, but they are numbered 0 through 39. And 3 channels, 37, 38, and 39, which are not next to each other, they are reserved for advertising, and the rest of them are for data. So I think we saw this advertising somewhere else before. I think it was in AD. Yeah, 60 gigahertz. I think in 60 gigahertz, we had 3 channels reserved for advertising. So basically what it is that when you want to send out something, everybody is listening on one of these 3 or all 3. And when you want to send out something, you send on this 3. But when you want to do something more than that, then you select a channel and you send the data on that one. So the 39 minus 3, 40 minus 3, 37 channels are for data and 3 channels for advertising. And it will become a little bit more clear what is done on advertising channel. So advertising channels are especially selected to avoid interference with Wi-Fi channels. So the reason they have selected this channel, and this channel here is because the Wi-Fi generally uses 20 megahertz, say channel 1. That means it might use from there to here, and then this one is not used. Then the next one starts, and something is not used, the next one starts, and this is the end. So they selected these 3 channels, which are not 1, 6, and 11 channels on the Wi-Fi spectrum, commonly used on those, right? So these 3 channels are used, right? And let's see how they're used. So there are 2 device types, peripherals and central. Okay, so peripherals are cheap devices, central are little bit more expensive devices. So if you have a phone and a headset would be peripheral, phone would be central. If you have a computer and a keyboard, you can see which one would be peripheral and which one would be central, right? Central has more power. And 2 PDU types, advertising and data. Advertising is of 3 different types, actually 4 different types. Non-connectable advertising. Non-connectable means no connection required. It's simple advertisement, broadcast and clear. Anybody can hear it. no big problem. I'm just going to say the temperature is 30 degrees. If you hear it, no big deal. If you don't hear it, then it's a problem. So basically this is broadcast in clear, which is most of the time what people are interested in. So if you're driving in a car, the speed, if it is advertising that you're going to 60 miles an hour, probably of interest to you, maybe somebody else can use that information. But if you want to do something in clear, then you use this mode. Non-connectable advertising. Discoverable advertising. In this case, you say some things and then somebody else may say, okay, all right, I'm interested. Can you tell me more? Right? So the original first message is just discoverable, right? Central may request more information. Peripheral can send data without connection. Here also there is no connection required because connection is a lot of time is spent on that, and for IoT we don't want to do that. And this is how we save energy too. So this is all related to minimizing the information transmission, radio transmission and things like that. So we do the minimum one. We don't want to do any connection. We just say in clear, okay, here is the information. So here discoverable means there could be a follow-up. General advertising, broadcast presence and wanting to connect. So general advertising is for connection, association, disassociation, right? So is anybody here? Can I connect to you? Is there a keyboard here? Is there whatever you want to connect, right? That is general advertising. This is more like for control. And directed advertising. And directed advertising means transmit signed data to a previously connected master. So this one requires connection. Is that you have already agreed to the let's say in my case, I have already my television has already agreed with my headset that they will connect. Whenever I turn this one thing on, turn both things on, then if either they both connect automatically or they both connect when I tell them to connect. Right? So I think when you turn on your headset and your phone, they automatically connect. Right? You don't have to say that please connect. Whereas in case of the television, I have to tell it every time I turn one thing on or off, I have to tell them that connect, and then they will connect. So anyway, so this is transmit data, signed data to a previously connected master. Now signed has to do with the security, right? So that signed means secure data because now we can be sure who sent it. So somebody else cannot play with my car and say, well, you're driving at 100 miles an hour when I'm driving at 50, or vice versa. Okay, so that is signed data. Signed data means it is, you can be assured whose it is. Now I am really little bit, I have a question in my own mind, why it is signed and not encrypted. But I think so basically signed simply assures the source. If I sign something, you can be rest assured that this came from me. Right? Encrypted means privacy. Means nobody can read it unless they have the key. Right? So this is signed, that it says signed. So this is basically source authentication. It simply says who the source is. All right? All right. So let's see. So this is a peripheral device. This is a central device. So it could advertise on all three channels. The peripheral could advertise on 37, 38, 39. And then the central could say, I need to, this is a advertisement from central which says scan request. Scan request is more on this side here where presence wanting to connect, right? And so this device says, yes, I want to connect. Scan response. And then they say, okay, connect. So all of this control can happen on this same channel 37, 38, 39. Basically, and the reason we have three channels is so that if one is busy, you can use the other one, or you can just keep listening on one, and then somehow the transmitter will come to that channel because they will transmit to that channel as well. So there are three channels for advertising. And so this one, for example, peripheral advertised on all three, and then this one requested on channel 30, whatever channel, and then on the same channel the response came back, and the connection request went back. After connecting, the master tells the slave about hopping sequence and wake-up cycle. So after the connection has been done, then it will tell you that this is the seed I am using for the random number generator, that is the hopping sequence, and the wake-up cycle, and that this is how often I am awake. All right, because this, even the access point can sleep, even the central can sleep, right? So your phone can sleep. See, the phone is talking to the headset, it can tell the headset that, you know, I'm going to sleep. All subsequent data transfer in 37 data channels. So the other channels are for data transfer. So if you are going to do any keyboarding and things like that, or in case of, let's say, different scenarios. So for example, my phone talks to GPS and Bluetooth, right? So if you're talking to GPS and Bluetooth, then all the future data connection will come on those 37 other channels. Initial connection will be on the 3 channels. Phone can also talk to a keyboard. Phone can also talk to a mouse. Phone can also talk to other devices like that. So all of that will be done on 37 data channels. Both devices can sleep between the transactions, as we know, and data can be encrypted. Yeah, right. So let's say GPS is a good example. So you don't need your position continuously. If you get your position every second, let's say, that's good enough, right? If you're going at 60 miles an hour, 1 second is probably too much. So let's say you need every half a second. In half a second, you can be off the road at most, a little bit, right? So you can sleep for that half a second. And that makes a lot of difference. See, whether you sleep for half a second or don't sleep half a second, you're a lot more fresher if you sleep.
Like knowing when is the next transaction.
Yeah, right. So all that is negotiated. See, the thing is, right at the connection time, the master told the slave, when master is going to sleep. And then after that, when the slave is ready to sleep, it can say, okay, all right, I want to sleep too, and I want to sleep every so seconds. So there are 2 kinds of sleeps. One is periodic sleep, and one is, just sleep, right? And so the thing is, both devices can sleep. So see, this is actually, here is an interesting thing. In the old days, we had to change the battery. The phones were so big, very thick, and most of it was battery. Right? Now the phones are so thin. Of course, the electronics has become thinner too, but the battery has become very thin, and we don't use it. So the reason the battery is lasting longer is not because the batteries have become any better. They have become a little bit better, but not 100 times. Okay, but the time of now, if I remember we used to have phone which we used to charge every 3-4 hours. It was just good enough for 3-4 hours. Now we don't charge it for days, and we don't miss it, right? I mean, if you don't use it, it can stay for a few days. And why it is? Because it is sleeping. Right? So what it is that the energy consumption, the battery, the life has gone up simply because of the usage pattern, not because of the battery technology. So there's a lot of sleep here. Data can be encrypted. So basically, during the connection, you can decide what encryption you want to use. So now here is how long the battery will last. This is a good calculation, and you should listen to this carefully because this might be in the exam as well. So let's say it takes 3 milliseconds to do the transaction. You do every 3 milliseconds a transaction. And in every transaction, you use 10 milliampere at 1.5 volt, that is 15 milliwatt of power. Right? If you use 10 milliampere at 1.5 volt, that is 15 milliwatt of power. And it takes 3 milliseconds. Multiply 3 milliseconds to 15 milliwatt, that gives you 45. Actually, multiply 3 milliseconds to 10 milliampere, that gives you 30 microampere per second microampere second per transaction, right? So if you have a battery which is 180 milliampere hour, so when you get a battery, it has ampere hours listed on it. Okay, so the coin battery may have capacity of 180 milliampere hour, right? So it is capable of conducting, if you divide this 30 by 180, 21.6 million transactions. And if you do the transaction 1 per minute, it will last for 40 years. Right? That 21.6 million divided by number of seconds in a year will give you 41 years. So you see, every millisecond counts, every milliampere counts. But this is how, now of course the battery will not last 41 years. This is a theoretical computation because of the temperature, because of the other things. The battery capacity may go up and down, and maybe the battery chemical may become bad after 10 years. You know, I mean, lot of things. I mean, a lot of times the battery just, you find the battery has this white thing coming out of it. The capacity is one thing, but the quality is another one, right? So, but this is how they calculate. You calculate how much energy you are going to use and how many transactions you are going to have and what is the capacity of the battery. The battery capacity is measured in ampere hours. The power is used is measured in watts, which is amperes times voltage, right? And then you multiply it by times, you get the energy, and so on and so forth. All right. So the bottom diagram simply shows that on the advertising channel, the peripheral said, I'm looking for somebody to connect. And this one says, okay, you can connect. And then once they are connected, then they have the data in the ACK, data in the ACK, data in the ACK. And then at the end, it will say end. And it will say, okay, done. In many cases, they would be sleeping in between these transactions. Okay, unless there is a file transfer, which can happen too on USB, on Bluetooth. But if it is not a file transfer, if it is like GPS or any other device, they would be doing a transaction going to sleep.